I'm Rodrigo Oliveira. I'm a principal software engineer at Gradle. And I've been developing the Gradle Kotlin DSL since the beginning. And I'm here today to share some of the things I learned during this process with you, right? Some of the tricks and tips that hopefully can save you some time in the future if you decide to explore this technology, right? And maybe, if I'm lucky, I can inspire you to build something really cool with this technology. And just before we start, I would like to clarify. So this is a talk about how you go about using this technology, the Kotlin scripting technology, right? To build something like the Gradle Kotlin DSL. This is not a talk specifically about the Gradle Kotlin DSL. I'll be glad to answer any questions, right, that you have. But this is about like how you use Kotlin scripting to your advantage to write your own scripting apps, okay? With that said, can I get just a show of hands of how many people use Gradle? Awesome, awesome. And how many of you are using Gradle with the Gradle Kotlin DSL? Great. And how many of you already use like build scans? Okay. So for those of you not using build scans today, I think the best Gradle advice I can give you is that you should run your builds whenever you have a problem, you are troubleshooting something, just run the build with --scan, and you get a lot of information from that, okay? That's the best Gradle debug tip I can give you to start with. Okay, so it was something like 3.5 years ago that Chris Beams, the original project lead of the Gradle script Kotlin project, as we call it at the time, right, revealed to the world what we've been working on, right? And it was like great reception, right? And at the same, in the same blog post, we could see what the very first milestone of the Gradle Kotlin DSL looked like, right? And okay, compared to the Groovy, counterpart of the same script, is a bit more verbose, and some things are not quite nice. But the IDE experience was there since the beginning, and that was great. That was like very promising, and that's why we persevered, right? And like even compared to what we have today, right? Like okay, but the thing is, we were able to get code completion, content assistance, refactorings, code navigation since the very beginning. That was really great, right? But we could only, have succeeded with the help of the Kotlin team, because like that was really early, in the lifetime of this technology. Like how early? Like if you check the date, that's the very first commit to the KEEP, the Kotlin Enhancement and Evolution Process, to the Kotlin scripting proposal, right? And that's 1 month after the first release of Gradle script Kotlin, right? So, like, things were really, like, wild, right? So, if you check the date for the first commit of the Gradle script Kotlin, or Gradle Kotlin DSL, as we call it today, right? That was even, like, 2 months even before there was even a KEEP, right? And it was really like the Wild West. Like, it was exciting for sure, but it was the Wild West, right? How wild, you might ask, right? Let's say we had to pay our dues, right? Like, that's how you would have to go to get the Kotlin compiler and the tooling to understand, that you want to enable some scripting application, right? And so I'm here to give you the good news, right? You are the lucky ones. And that's great, right? Now we have a new KEEP. And the API there, it's awesome. Like, it's partially implemented in 1.361. Not everything is there, but what's there is already like plenty, right? And 1.370 has much more like goodness in it, right? So what's a scripting application, right? What's the scripting about? For me, it's all about the experience. I know that's like kind of fuzzy, like new age kind of talk, right? But I hope that I can show you better than I can, maybe explain to you what I mean by that. And before we go into like the use case of something like the Gradle Kotlin DSL, which is maybe it's more complex and has more details, let's look at something simpler, right? Let's look at turtle graphics. Who knows anything about turtle graphics? Yeah. So turtle graphics is this idea, right, of like drawing like vector graphics by using like a cursor that is represented here by the turtle. And the turtle can actually like move forward, backward, right? It can rotate, right, left. You can put a pen down, pen up. You can choose the color. And people actually control this robot using this language, a programming language called Logo, right? Can you imagine like how fun that must have been, right? So the way you control that turtle, the way you do turtle graphics, right? You can issue a bunch of commands to this turtle, right? So I can tell the turtle to move forward. I can tell the turtle to rotate left, to rotate right, right? I can choose which color like which pen you should use to actually paint. I can put the pen up, right? So I can walk and not draw anything. But those are basically the primitives that you have, right? And the thing is, when you have to actually write like a turtle program, right? If you would write it like in the traditional way, like a traditional app, I'm going to write like a turtle program, right? So sorry. So let's say I have my turtle graphics API, right? And I want to write, oh, sorry. How can I switch back to the app? Anyone else? Home? No. Sorry, I'm just a programmer. That's all I can say. I know that's not an excuse.
Well, you have to mirror your display. So you'd have to go into... Is it that? No, it's not. So you can now go out to the desktop.
Yeah.
So you can just turn that down. Close that down also.
You want this?
Yeah, just to minimize it. Minimize it. So, it is here. Yeah, system preference.
Thank you.
So now you have
Mm-hmm.
what you see there is what you see.
Perfect. Thank you. Okay. So I have my turtle library, right? My turtle graphics library, and I want to write an app, right? A turtle program. So, okay. I'm going to go like to the main, right? Because that's what we do in programs. You have like a main somewhere, right? Where you can write code and, okay, I see that I have a library here where I can do eval and write a turtle program. Luckily for us, right? Kotlin has this feature like implicit receivers and extension methods, right? Where we can actually inject some context into some function so I can have a sort of like a DSL, a domain-specific language for that function, right? So inside this function, I can then write stuff like, okay, I'm gonna, let's say, turn left 9 degrees, right? And then I'm gonna move forward by a certain distance. And maybe I'm gonna like, repeat that 4 times to get a nice, square. Yeah, but now I'm in this program, I have to maybe compile it, run it, right? So that's the experience we have when we write apps, right? You write an app and you run it, right? And then you can see the output, okay, I got my square there, awesome, right? But now I want to change this app, right? To change my program, I have to go back there. That's not nice, right? There's a lot of context around my Turtle program that is not related to my Turtle graphics, right? I have like this imports, I have other functions that I don't know what they're about, right? So this is not ideal if you just want to focus on the Turtle graphics stuff, right? So let's see what a different experience could be like, right? What if I have like just, you know, a blank sheet of Turtle page, Turtle graphics page, right? Ready for me to write something, right? So now I can write, you know, my Turtle program, right? I can do the same thing. And now that I removed like all the clutter around, right? I can focus on my task. But also, now that I can have like this sort of like Turtle programs as separate documents, I can also like more easily, you know, compile, load, just that specific thing I'm working on. So I can do things more incrementally. For instance, I could have like a Turtle preview, right? Where I go and save and start seeing things, right? So I can go and do again, like repeat 4 times, right? And I can start seeing some stuff. Maybe I want the color to be like red, just because, right? Who doesn't like red? So then maybe I want to repeat the whole thing. Again, maybe. So I'm going to do like 36 times. Oops, sorry. And I'm going to like turn the turtle by 10 degrees, and then we start getting some stuff that's too small, right? But let's make this really big. Right? And I can play with it like very easily, right? I can have like almost like instant feedback of the things I'm doing. And that's what I mean by the experience, right? So that's what a scripting experience should be like, right? So now I'm going to back to the slides. And I hope everything works. Nice. Yay, technology. So what's the scripting experience about, right? Is when you remove all the clutter, right, you can focus on the thing that you want to do, right? But you also remove a lot of overhead, computational overhead. Now you can actually have more of this instant feedback cycle, right? And that's really, really, really great. And the thing is, with the keep as it is today, it's very, very easy to do just this, right? So I'm going to go through now the basic, like the 3 simple steps you have to do to get like the IntelliJ idea, to recognize your scripting application and provide the same level of like experience I just showed you, right? Like content assist, code completion, and all that, and navigation, sorry. So a Kotlin script, like application, a Kotlin scripting application is defined first and foremost by a Kotlin script definition, okay? The Kotlin script definition is this class that becomes, by default, the base class of your script. You can imagine that your script is going to be compiled, right, into a class. And that class will be like a subtype of your Kotlin script definition, right? In this case, we have like a turtle script that requires some turtle, like to issue commands to, right? And here we are using like this simple trick of using like Kotlin interface delegation, right? Like the turtle by turtle. So I can inject all the turtle names into my script. So now my subtype, right, can see all the methods of the turtle command. So that's how my script can see all the types. I can give a file extension, right, to my script. And the other very important piece of information is the third script compilation configuration, right? And that's the second thing you have to do. So the turtle script compilation configuration basically tells the compiler and the IDE what the dependencies are for this script. When you have a script, what jars you need to actually compile it, right? And you can actually tell the IDE, for instance, I want my users to store their scripts anywhere in the project hierarchy, or you can limit, the scripts to only be like at the project root level and other places like that. And you can inject interesting names, right, interesting types into the scripting context, like the color, so I don't have to actually remember that it's Java AWT color or type or have an import, right? So you can inject all the interesting names in there. And finally, the third piece of information you need to give the IDE, and that's the final thing, that's all you have to do, right? Is just this file with the name, right? This class name file is basically an empty file, it's like a advertisement to the auto-discovery system that you have a script definition somewhere. And that's it, right? Just by doing that, you get all the goodness I just showed you. Isn't that amazing? Like, how cool is that? So then to actually execute the script, you just have to do a little bit more work, but that's basically what I'm showing you here. So you instantiate this JVM scripting host that is provided by Kotlin to you, and you ask this scripting host to evaluate a given script, a piece of source code, against the template, and that's it. So in this case, we also have another important piece, right, that goes with the eval call, which is the evaluation configuration, which must match, right, the compilation configuration. So I said my base type requires a constructor argument because it requires a turtle. So I have to give it a turtle here. And that's it. So now let's talk about like a more complex example. Like talking about Gradle would be maybe a bit overwhelming because there are many issues that we have to care about, and I want to focus on the Kotlin scripting experience. So let's see like a smaller version of Gradle that I'm calling like Gradler. So Gradler is like the Gradle toddler, right? I actually had to look it up, like Gradler, just to make sure, like, I'm not a native speaker, as you can probably guess. So you never know, you have to look it up in Urban Dictionary if that's some curse word or whatever, right? You never know. So I don't want to violate any code of conduct, which is great, by the way, to have one. So Gradler is a lot like Gradle, right? So the main interface, right, around the configuration of this tool is the project interface. So Gradler lets you define projects, and projects have tasks, right? And you can configure tasks, but projects can also have extensions, and these are like POJOs or rich objects that are contributed by plugins, right? By add-ons to your project to add interesting information to the project model, right? Tasks can perform some work, can depend on other tasks, right? So it's, if you know Gradle, you know what I mean. And action allows you to execute some configuration against an object. The important thing that I want you to notice, all these interfaces that I've just shown you are Java interfaces, right? And that's what add a bit of complication, right, to the whole mix. Because before, we had pure Kotlin code, and now we have Java. So we have to take some steps to make sure the experience is actually great as it should be, right? So we do basically the same thing that we did before, but let's first take a look at what we're expecting the experience to be, right? So we want to provide an editor to the user that allows the user to write something like this, right? So I can add plugins, right? I can declare plugins, so I'm declaring like a Kotlin plugin. And the Kotlin plugin actually contributed this Kotlin extension to the project model. So now I can actually just type Kotlin and configure the Kotlin extension, right? And I can define a task. And notice that when I configure the task, I'm actually getting like a receiver, like an implicit receiver in this block, in this lambda. So I can just say depends on. I don't have to say like something like give a name to the task variable or use it or something like that, right? And there's a catch here. We also want the experience to be like safe in the sense that it's statically typed, and safe in the sense that if a user didn't declare a plugin, didn't apply a plugin, or didn't declare that he or her is using the plugin, right? We want to make sure we get errors like this in the IDE, right? So if you have a plugin, it's all good. If you don't have a plugin, I want to have feedback, right? So we define our Kotlin script definition as before. This time, we have to take care of adding this thing that didn't belong to the original model, right? The plugins. So plugins is something that is coming from the DSL, from the scripting experience. So we just add this method plugins. So this allows the IDE to give code completion for plugins. We don't actually need an implementation, right? Because what we are going to do is we're going to inspect the script before we compile it to see if the plugins block is there, and we're going to handle it before the Kotlin compiler has a chance to do anything to it, right? And then we just define a nice interface so we can declare IDs, right? So we're using, again, like the implicit receiver there. Great feature. And OK, so we give the IDE this definition, and this is the experience we get, right? We're getting there. But there are some things that are not quite nice, right? So the first thing that calls my attention is like this parameter name, like P0, right? This kind of like sticks out. So I want to take care of that first, right? So that's easy, right? We basically tell that the compiler we're using Java 8. We're going to use, the parameters. We're going to preserve the parameter names in the bytecode. And we tell the Kotlin compiler, right? We want the Kotlin compiler to actually consume, those Java parameters, right? And this is a Gradle Kotlin DSL script, right? If you've never seen one. So we're using the Gradle Kotlin DSL to create these other DSLs. OK, so now the experience is a bit better, right? Now we have this parameter name. But the other thing that sticks out to me there is that we have like this task, like this bang, like the platform type. So I don't want my users to bother with platform types, and I want like null safety, right? So that's easy enough, right? So there's the JSR 305, right? I think it's like annotations for something like defect detection or removal, right? So by doing something like this, right, creating that interface, that annotation definition there, and then declaring the annotation on the package, we tell, the Kotlin compiler basically that my API has no nulls, right? It's a non-null API. So if you see a string, it's a string. If you see a task, it's a stack. A task is not like a task, question mark. OK, getting there. So now we have like depends on and perform, right? They are in red. That means the compiler doesn't know what I mean. And we have this it there, right? As we used to call it, the dreaded it problem. So, oops. So that's a bit more involved. That's probably one of the features that I think we got the Kotlin team to implement specifically for our use case, which is great. Thank you very much. Big shout out to Ilya Chernikov. Thanks, man. So the main thing is, you can see your script definition, script compilation configuration right on the bottom left. And it has this configuration, right? Annotations for SAM with receivers. So you give that configuration the name of an annotation, right? And that annotation can live anywhere, right? It's your own annotation. So you don't even have to take a dependency on any Kotlin libraries if you don't want to or can't, right? In our case, we couldn't, because that was like Gradle core interfaces. So we needed to be able to tell the compiler from the outside, right? And then you have the annotation, and then you apply that annotation, right? And I made a mistake there. I'm sorry. So the SAM with receiver on the right should be on the action type. OK, so where you're reading task, you should read action, and it should be the action interface. I just saw that out. I'm sorry. But once you have that, right, that's it. You get the experience. Now, basically, action T becomes like T dot, parentheses, unit. So it's like a implicit function, or implicit function with an implicit receiver. Yeah, so now the last piece we need to solve, right, because we still lack some refinement to our script, is the extensions, right? So let's take some time and digest that. Don't worry. So this is inside the compilation configuration, right? I'm adding some stuff to my compilation configuration. I'm telling the Kotlin compiler that whenever, right, it needs to compile my code, right? Before compiling my code, I actually want to look at the code and refine the configuration. You can basically add more imports, you can add more stuff to the class path, right? You can change everything about the scripting configuration at that point. So what we do here, right, we just look at the script text, we see if there's a plugins block. If there's a plugins block, we go, we resolve, the plugins declaring that plugins block, however that happens, right? It's going to be, in the case of Gradle, right, we actually compile the plugins block as a separate script with its own, Kotlin script definition and its own configuration, its own environment, right? So we can provide a nice experience. And then after that, like the result of this process is a new class path, right? And the other thing we do, right, during this process, and we can do, right, is that we generate code. So we basically go, okay, so if we're going to use the Kotlin plugin, and then we apply the Kotlin plugin, and the Kotlin plugin actually contributed, extensions to this project model, we go and generate Kotlin code, like just a bit of properties and functions to let you statically access, right, those members so you can get a great experience. And then we, in this case here, in this like mini Gradle version, we also add a few default imports. So we assume all the extensions must be in this Grawler.extensions, right, namespace. And now that's how we can actually use, this new property and anything that the plugin contributes, right? And finally, we update the class path, right? So after we did that, right, we get the whole thing working. I rushed through a bit, I'm sorry, so maybe that was too short, but I'll be glad to answer any questions you have and help you with anything. Thank you.